1981 we opened our first branch here in Ireland, in Ballymount. It's still there today. And in 1983 we actually sold our first heat pump. And it went to County Sligo. And the installer that put that in is still a customer of ours today. He does send regular photos in every now and again of the unit and service. So there's a wee bit of history. We've over 120,000 employees. We've a turnover of 44 billion. And as a group, as Mitsubishi Corporation, 220 billion. So we'll be one of the biggest in the HVAC industry. We are broken into four main subcategories. We have air conditioning, ventilation, IT cooling and heating. I always say to anyone, if you're ever at a hotel, you're up high, look down at the rooftops. If you're driving the road, looking at the shops, you'll see the three diamonds of Mitsubishi everywhere. So we simply took that technology that we had developed all these years and we put that into our air source heat pumps. So, ecodan, the natural evolution of home heating. So back in the day, a couple of people got together inside a cave and they lit a fire. And they said, I think we're on to something here, lads. And that was the birth of thermal energy. We go across to the Tudors, our wood burning hearth. The Georgians, we had our coal stove, which was a big thing in the industry at that time. Our Victorians, we had the open coal fire. Then the 1930s, see the old electric heater. So we 1 kilowatt electric heater. We put a kilowatt of power in, we got a kilowatt of power out. Then we moved across to the 60s. There was the evolution of gas boilers, completely changed the industry. It was the birth of heating as we know it. And then we moved now to the 21st century where we're looking at our renewables. We're looking at a greener heating network. So we wind, solar, thermal, air source, ground source, water source heat pumps. So why heat pumps, why now, and what's wrong with your gas boiler? So hopefully by the end of this, you'll have took a wee bit more information than you had before you started. So global warming, climate change. We have to reduce our carbon emissions by 51% by the end of the decade. To put that into numbers, in the next 7 years, we have to have over 600,000 heat pumps installed. Massive numbers to hit, and also the climate action plans. This has continually been reviewed as we're going along. I always say, a picture paints 1,000 words. This is the actual BER roadmap of Ireland. This is every home in Ireland's current BER rating colour coded. So the best BER rating we can get is an A, the worst we'll get is a G. So we're colour coded from green down to red. So you can see there's a lot of yellows, which is a C, and then reds, which is down to E, F and G. In the next 7 years, half of that has to be turned green. By 2050, that all has to be turned green. So we've a massive target to try and hit to get there. The government's took kind of a carrot and stick approach, where they're feeding us, where we get a grant for €6,500 towards the heat pump, but then you're hit them with your carbon taxes, and that's the stick if you don't make the jump. Part L building regulations as well if you're doing a new build. So Part L compliance, so I'm 16 years in this industry, and I've seen Part L evolve as we go along, and Part L is your heating and energy contribution for your property. So it used to be you put in your condensing oil boiler, that got you over the line. Then we seen the introduction of an oil boiler with solar thermal. Then that started to increase to solar thermal plus PV. And now we're at the point where the easiest way to get your Part L compliance is with an air source heat pump. It's a much more comfortable way of living. You can still get Part L compliance with an oil boiler, but the amount of PV or solar thermal that you have to do to contradict that, it's very questionable if the outlay is actually there. So who here owns a heat pump? Okay, very good. Well, the truth is, I'll not say we all have one at home, but we all have the basis of the technology at home, and that's in the form of our fridge. So our fridge and our heat pump does the same thing. We take heat from one part and we dump it out to another. Our fridge takes energy from the food, dumps it out the back. That's why your back of your fridge is hot. A heat pump, we take thermal energy from the air, and then we dump that there out through the front. So if you had 6 degrees ambient temperature going in, you stand at the front of your heat pump and it's 0. So where does that 6 degrees go? It goes into your home. And that's why they're so much more energy efficient, and you get much more thermal energy out of a heat pump than you do out of your traditional gas and oil boilers. So the main components within your fridge, the exact same components as inside your heat pump. We have our evaporator, our expansion device, our condenser, and our compressor. So what we're doing with a heat pump, The back of it's loaded with liquid refrigerant. We take in high volumes of air, we turn that liquid refrigerant into a gas, and then we put it to a compressor. And like a compressor, like your bicycle pump, you heat it, and then that gives us then the heat and thermal energy for our space heating and our hot water. COP efficiency. What COP is, for the power that you put into a heat source, it's what thermal energy that you get out the other side. So a heat pump, you put in 1 kilowatt of heat from your power, we put in 3 parts from the energy of the environment, and then that gives us around 4 parts out to the property. So that's why units are around 300 to 500% more efficient. For the 1 kilowatt we put in, we're getting more value for our money out the other side in terms of our space heating and our hot water. So one of the common questions we get is, do they work in cold temperatures? They absolutely do. The only difference, 0 degrees, all 0 degrees is the point at which water freezes. In terms of refrigeration and heat pumps, absolute zero is minus 273. So that's the point which we can't take any more energy out of the air. I've had quite a lot of meetings in Europe for Mitsubishi, so we're dealing with the Nordic companies, Sweden, Scandinavia, Denmark. There's a reason why them cold countries and primary heat sources are heat pumps. It's because we can pull that energy efficiently out of them low temperature air. So reduce CO emissions, reduce running costs, and no risk of carbon monoxide as we would have with our fossil fuel led boiler. But what no one ever really talks about is the level of comfort that you get out of a heat pump. So you're going to be building your properties now up to an A1 or a B2 standard. You're losing your heat in very, very small droplets. So it only makes sense to take that heat and send it back in the exact same fashion. So it's much, much easier to introduce small amounts of heat and spread that over a long period of time. I always compare that to your car. You're driving down the motorway, you'll start to see your range of fuel rise, and that's because we're going at a steadier pace over a longer period of time. So I done this on Thursday, heat pumps versus oil and gas. So this is an A2 rated new build, 160 square meters. Your BER report will tell you what the energy requirement is for the house. Total energy requirement was around 8,400 kilowatts. We take this across. Now bear in mind, oil prices dropped at a considerable amount in the last few weeks. So in order to generate 8,400 kilowatts of thermal energy, your gas and your oil boiler had to consume, your oil had to consume 9,400, your gas had to consume 8,900, and your heat pump only had to consume 2,900 kilowatts of power. The efficiencies drop on domestic hot water, and that's because you're raising your temperatures up to get up to 60 degree flow temperatures. We take that into costings. Gas, 1,195 per year. Our oil was costing us 890. I done this 3 months ago. Yeah, oil was costing around 1,100, and our heat pump was around 790. But fossil fuel prices are intermittent. They're going to continually go up and down. So, typical installation. You have your heat pump outside. It can go on the ground. It can go on the wall. And then inside we've got our cylinder. Again, that can go in the utility room, the kitchen, or it can go inside in your hot press. Typical layout. So we have a room stat, either on each floor or in every room, and your room stat is your main call for heat. Everyone has a different preference. Average person has around 20 degrees comfort living. Sector stat at 20 degrees, and simply let the system do its work. Don't touch it, you don't turn it on and off. You don't have time clocks, you do like you have with traditional fossil fuel led heat sources. And then we could use either underfloor or radiators. Either or, it makes no difference. So, ecodan. Ecodan is the Mitsubishi Electric brand of our air source heat pumps. So what's different about ecodan? All our products are manufactured over in Scotland. So all heat pumps have to do a defrost cycle. And over here in Ireland, we've higher levels of humidity. If you're over in a colder country, like Sweden, or if anyone's ever went skiing, you could be outside in minus temperatures wearing a t-shirt and you still feel warm. We start getting frost periods here in Ireland, anything from 2 to 5 degrees. So it's very important that the system is designed around the Irish climate. So this facility was built specifically for Ireland and the UK. Intelligent control system. So we use, with time and temperature control as standard. You have to have it as part of your building regulations. We don't recommend it's used, but the option is there. Self-learning capabilities. the Mitsubishi Electric stats will actually start to learn the habits of the room and correlate the temperature to suit. And the systems are all Wi-Fi compatible with energy monitoring built in. The energy monitoring is very important because everyone wants to know how much is the heating system actually costing me. So what we can do with the energy monitoring is you can actually see it as the current month, the previous month, 2 months, current year and previous year, and we log everything on an SD card, which is basically a SIM card that's telling us everything that the system's doing and everything that your house is doing as well. Auto adaptation mode, as I said, heat pumps want to work at lower flow temperatures. So for every 1 degree we can drop that flow temperature, we'll increase the efficiency of the system by about 2%. SD card logging, as I said, this logs everything. So whenever we get calls to say that my heating system's not working or think of high running costs, no one ever tells you the true story of what's actually going on if they're turning it on and off. So the SD card, we take it out and we can simply see exactly what that system's doing. And then it's just a matter of education to advise and guide the best way to use your system. Then we have our Mel Cloud, so Wi-Fi compatible. We can set the system up to work on your phones. So it'll bring up a pie chart or a bar chart. You can actually input how much you're paying for a kilowatt of electric, and it will spit out your domestic hot water cost, your space heating cost, and what the overall total is. And we've also timer functions, holiday modes, and you can set each of your room temperatures as well. Hot water. Traditional systems would use a coil. So what you do is you heat that coil and then it heats the water in the side of the cylinder. We use a plate heat exchanger. So what that does is that will actually force that heat from coming from the heat pump out much quicker than you will through a coil. So we're using what we call forced convection versus natural convection. But more importantly, you've no displacement of the cylinder. So a typical coil inside your cylinder, you could lose up to 30 litres of system volume. So when you think you've 200 litres, you might only have about 170. So when you take that coil out, you're getting a greater volume of water, stored water inside your cylinder. Applications, new housing, we're involved with Clued, Respond, local housing authorities, schools, apartments. The dairy sector, we have heat pumps that can generate hot water temperatures up to 90 degrees without the need for any backup heaters. That's big business for us at the minute. Hotels, nursing homes, leisures. We take a lot of calls for swimming pools. And retrofit. The retrofit markets, it's the biggest market out there at the minute, there's no doubt about it. So just to summarise some of the benefits. So it's the most easiest way to meet your Part L on your new build. Lower running costs than your conventional fossil fuel-led systems. As I said, your energy delivered will always be greater than what your energy is consumed. Higher levels of comfort, and we're going to provide 100% of your heating and domestic hot water. So your wind, your PV, your solar thermal, it's all intermittent. Depending on what the season is, heat pumps aren't. So we're getting 100% space heating and hot water all year round. So, any questions?
Yeah, when I look at your figures here, the difference is not enormous between, the oil. I mean, how long does it take to work out the cost of the system? It's like only just a couple of €100 a year saving.
Yeah.
Surely this system costs thousands.
The initial layout of the system, depending on the size of the property, you could buy the equipment from anything from 5 to 10,000. Now, bear in mind, the price of gas and oil has completely plummeted in the last number of weeks. If I was doing that 2 or 3 months ago, the ratios would have been much greater. But we're looking at it in cost, but we're also looking at changing the comfort level within your home as well. So as I say, a heat pump, it's anyone that has a heat pump and it's working right, no one ever comes up to you and says the cost and savings great. They will all tell you that it's a much more comfortable way of living than what they were getting with their traditional fossil fuel-led heat source. So I tell anyone there's a decision that you have to make personally yourself if you want to go down that route or you want to keep what you have. So.
Right. At the moment, I'm upgrading the house.
Sorry, where are you?
Hello.
Sorry.
Yeah.
Sorry.
So at the moment, I'm upgrading the 1960s bungalow.
Yeah.
9-foot ceilings. I have a roof suspended wooden floors to allow for 150 mil insulation.
Yeah.
To prove that. But with the heat pump, which I'm thinking about doing at the moment, The one thing that may put me off is the air pressure test, because I have to achieve a serious good air pressure test. Now, I did go ahead with triple glazed windows, triple glazed out throughout the house, but I'm wondering, what is the air pressure test that I have to achieve on a retrofit? Surely it can't be the same as a new build, will it?
No, so your house doesn't have to be airtight, okay? So as long as you're getting to a B2 energy rating, that takes into consideration fabric, ventilation, and your air tightness. Now, an air tightness test on new build is 5 air changes per meter cubed per hour. So you could be up into anything to 7, up to 7 maybe with a retrofit. We do loads of retrofits, thousands of them, and none of them is going down the route of the air tightness test. They're upgrading their fabric, their windows, the doors, and it's enough to get you over the line. All right.
What are the criteria for the exposure of the external panels? What exposure do you require? Does it need air? Does it need to be exposed to the sun? Or what is the story on that?
It doesn't matter whether it's north, south, east or west facing, as long as you've at least 2 metres of clearance at the front of the unit and around 1 metre on each side. That's more than adequate for us to pull in air. What we don't advise anyone to do is to come with like a wooden box and try to cover in the unit in the garden. So it's pretty flexible with where you can put it. The sun exposure has no effect whatsoever on the running of the unit.
Okay, another question was about the exchange plates you had for the domestic hot water.
Yeah.
They seem very bulky, are they?
No, they're very small. If you were just at the back of this stand here, if you wanted to come over afterwards, I can show you. It's inside, pre-plumbed in the cylinder. It's only about that. But that's very, very small.
Okay, thank you.
No problem.
What about noise levels?
They're very, very quiet. I do a lot of the training in Dublin. So the inside unit is inside. The decibel level on them is around anything from 38 to 45 decibels. Other than feeling the air coming off the front of the unit, you wouldn't actually know that they were on. They're very, very, very quiet.
Maybe you've covered this already, but can you tell me, do you need to upgrade the radiators when you put in a heat pump?
Yeah, generally you do, because your traditional boiler, your gas boiler, is working at 75 degree flow temperatures. Your heat pump's going to be working at around 45, so it's much lower. So to compensate that lower temperature, you have to increase the size of the heat emitter. So what you do is you do a room by room heat loss. That will tell you what your output's needed for the room. And then you can simply just check that against what the radiator output is. Now, back in the day, installers tended to oversize everything. So no one ever took a calculation for a room. There's a good chance your radiator could already be big enough. But when you're going to the extent of to do a retrofit, you may as well change out all the radiators because it's a very, very low costing.
As I understand, the temperature is regulated, it's always the same. Is that the same principle as well for water? So you constantly have hot water?
Yes.
Are you effectively making it like an electric shower redundant?
No, yes, you are. Because we set the hot water at, say, 50 degrees, and then we set a 10 degree drop off point. So the minute the system senses that the water in the tank has dropped by 10 degrees, we'll start to replenish it straight away.
We heard you can put works better with the underfloor heating.
Yeah.
Is it correct?
It will work with either or. The only difference is underfloor heating requires lower flow temperatures, so 35 degrees. And as I said, the way the technology works, the lower, for every 1 degree that we can drop that flow temperature, we'll increase the efficiency of the system by up to 2%. So the lower the flow temperature, the better the efficiency. Radiators are working at around 45 degrees. But one thing I tell everyone is that temperature of 45 degrees is at worst case scenario. So that's designed 45 degrees at -3 outside. We set the system up on a weather compensation curve. So what that does is that monitors the outside temperature, it monitors the flow temperature, and then it will adjust that to suit. So most times of the year, you're probably working in around 30-degree flow temperatures, except for when we get down into that -3, it'll go up to 45 or 35 in this case for the flow.
So when a heat pump doesn't work, what are the typical reasons? So is it like air tightness, for example? So my fear would be you invest in it,
Yeah.
and then when you realise it's not working, it's not about moderating behaviour or something, it's actually something really structural.
Yeah, so that's something that has to be obviously watched very hard. So there's no reason in this day and age that an installer or a contractor shouldn't be getting a new build up to an A1 or an A2, or a retrofit up to a B2. So anytime that we have issues with costings, it's generally never down to the fabric of the building. It's someone who's played around with the setting on the heat pump. So there is a level of responsibility that's outside of our realm that falls in the arms of the contractors to make sure that the buildings are up to adequate standards.
Is the indoor unit connected in the attic? Or is that
Yeah, no, you can put it in the attic. So traditionally, with traditional systems, you'd have had a tank in the attic. Okay, so with heat pumps, generally, we pressurise the system. So we're doing away with all the tanks and stuff. So you have mains pressure at your domestic hot water and cold water taps. So yes, to answer your question, the cylinder can go in the attic. No issues.
Hi. Shane, thanks very much for your presentation.
Well,
Appreciate that.
thank you.
Just going back to Amy's question about outages. We heard somewhere as we were walking around that there's a power outage that the unit has to be reset. Is that complicated?
No, it will generally reset itself. If the power went out for maybe 48 hours, there'll be a red warning light will flash on the unit. You just hit the button and away it goes. All the settings will load back up automatically.
And the second question is it possible for an individual to calculate the number of units you need for a property, or do you need to get a specialist to say you need 2 power pumps and one?
You do that through your BER assessment. So your BER assessor will tell you what the total heat loss is on the property, and we have to be fit to 100% replace the heat loss with the heat pump. So that calculation will be done by your energy assessor.
Hi, we just retrofitted our house recently. I'm just wondering about the radiators upstairs. They don't seem to be, synchronized to the same heat as downstairs.
The cold?
Yeah.
Yeah, so a heat pump's a different way of living, okay? So your radiators could be cold, or they could be lukewarm, but your home will be warm. Now, if you've only just recently done it, I tell anyone there's a bit of adjustment there. You have to get used to the home, and the home has to get used to you. So you might have to play about with the stats. So your upstairs temperature might have to be increased by a degree versus what your downstairs is, and just try and find that balance. But I wouldn't be alarmed that the radiators are only lukewarm or off or cold. It's because we're trying to heat an area rather than heat an emitter for a period of time with hot water like you did with your traditional fossil fuel. But you can talk to me. I'll be back at the stand and you can come over, yeah? Thank you.